Alright, so here we're going to talk about solutions of an equation, and specifically we're going to be trying to, or making sure we understand, what does it mean for something to be a solution to an equation. So we can see in our note packet that when we're talking about a solution, here for now we're referring to a solution point. There could be an infinite amount of solutions to an equation, there could be no solutions to an equation. And if there are an infinite amount, then each one of those solutions can be written as a specific point. If there's an infinite amount, you don't want to write them all out, though. That you would probably, by probably I mean you definitely would die before you finished. So that's a sad thought. So don't do that. Alright, so what do we mean by solution? We mean an ordered pair or a point that makes the equation true. Another way to think about it is a point on the graph of the equation. So if you were to graph the equation, then the graph would go through the point that is a solution. In fact, the entire graph is all of the solution points. So I want you to use two different methods to show that the point 2, 0 is a solution of the equation y equals x squared minus 3x plus 2. There are, depending on how you think about it, more than two methods. So I want you to just try to come up with two different methods to show or verify that this point is a solution to this equation. So I want you to pause the video, do that, unpause when you want to discuss, and by discuss I mean listen to me speak again. Okay, so I'm going to show you four different methods. The first three are actually all very similar, but they are slightly different thought process, so I want to show you that and point that out. So the first one I did was I plugged in the y value to the equation and I solved for x. So if I plug in 0 for y, I can factor the right hand side of the equation into x minus 2 and x minus 1, set each factor equal to 0 only because the equation equals 0, and when I do that I get x equals 1 and I get x equals 2. So there are actually two values that make that equation true, but in this case all I was looking for was x equals 2, so I verified that 2 is a solution, or I'm sorry, that the point 2, 0 is a solution. The next method would be doing the same thing but in the opposite order, so plug in 2 for x and see what I get for y. So if I plug in 2 for x, I have 2 squared minus 3 times 2 plus 2, which is 4 minus 6 plus 2, which is 0. So I get y equals 0, therefore I verified that the point 2, 0 is a solution. The third method would be to combine both of those and plug in 0 for y and 2 for x at the same time. Make sure that the left-hand side of the equation does actually equal the right-hand side of the equation. Both of them simplify to 0. 0 does equal 0. That's a true statement. So therefore I have verified that 2, 0 is a solution to the equation. Then the fourth method would be graphing. Graphing is a little bit more difficult, only in the fact that it's more work. You could use your calculator, you can try graphing by hand, but it's not always going to be as obvious when you're using a graphing technique some of the times. In this case it's pretty obvious because it's also going to be an x-intercept. But here, if I look at my calculator, I have the equation typed into my y1, and if I look at the graph then, you know, it might be hard to tell. We might want to zoom in. We can do second table, and we can look at the table, and if I change, or if I type in, let's see, 2, I see that y equals 0, or if I do second calculate, I can put in a value for x on the graph, and let's put in 2, and we also see that y equals 0. So those are some of the ways in which we could verify graphing. But again, it's a little bit more cumbersome with the graph, perhaps. Not always, but sometimes. So you don't want to count on the graph. Okay, so those are a few ways to verify that a point is a solution to an equation. Or if you aren't trying to verify that, if you're trying to determine if it's a solution, those are a few different techniques. And again, if you're trying to determine if something's a solution, you know, when you look at my steps here for 1, 2, and the first three different methods that I used, You might say that they're actually all doing the same thing. Well, depending on how complex the equation is, one of those methods might be a little bit easier than the other. So any of them are correct, though.